So another process that is central to baking is that of making bubbles. You all have the experience of making a cake or making bread or eating a cake or eating bread and cutting it open and finding that inside there's this enormous array of bubbles. And you know from your experience that the bubbles and the way that they're structured affects the texture, affects the way that the cake or bread or baked good feels in your mouth. Now, Joanne showed us, when she was showing us how to make cake, the importance of creaming butter for making bubbles. She told us that the way that one actually gets bubbles or air in general into a batter is by actually mixing the sugar into the butter. And she described this wonderful thing of the little sugar crystals being what she called shovels, which shoveled out little air pockets within the butter. That's when the butter gets light and fluffy. And then when you fold the flour in, and then you start to have the ingredients of the batter that you need to make a wonderful cake. Okay, so our goal for today is to think about how these initial seeds of air, or these initial bubbles that are placed into the batter, grow and merge into the remarkable structure of bubbles that you see when the cake is actually finished. And what we're going to do, so this is actually a rather complicated process, as you can imagine. There are all of these bubbles growing, and they're growing for a large number of different factors. But what we're going to do is focus on a very simple problem. We're going to imagine that we have a single bubble that is enclosed, that is surrounded by batter, and we're going to talk about the conditions under which the single bubble grows, and what makes them grow, how fast they grow, and how this depends on the recipe that you use. And then at the end, we're going to summarize how the lessons that we've learned from this single bubble apply to thinking about the physics of the entire cake or bread or whatever it is that you're trying to make. We've talked about bubbles before in this course. In fact, we talked about them last week in our study of emulsions. And you'll remember that Dave showed you this wonderful picture of what was then an air bubble that was surrounded by liquid. And the air bubble was within the foam. And what Dave told you about was this concept that he called Laplace pressure. Laplace pressure was the idea that if you have a bubble, energetically the surface of the bubble costs energy and it wants to shrink. And so the surface of the bubble actually tries to pull inwards. It's the effect of so-called surface tension, which then, in order for the bubble to remain in equilibrium, has to be balanced by a higher air pressure inside the bubble than outside. And we wrote down this wonderful equation that says that the pressure difference across the bubble, in order for the bubble to be in equilibrium, is twice the surface tension, which we called sigma, divided by the radius of the bubble. Now, when Joanne creamed the sugar, there were almost certainly little tiny air bubbles that were then dispersed throughout the batter after she was done, that came from the little shovels of the sugar crystals that were making the air. And it's worth thinking for a moment about this Laplace pressure equation and thinking about what's going to happen. So you see, the surface is curved, and the surface must have a surface tension associated with it, because all surfaces do, and so it wants to close. And so an interesting question to think to yourself is, why does it not close? That is, why do the bubbles not close up upon themselves? And there are, from what I can tell, only two possible answers to that. And I should say, I don't know if this is right, but I can only see two possible answers. So one is that, as Dave also told you last week, one can sort of get rid of the surface tension of an interface by adding surfactants. So surfactants are, of course, proteins which have one side that like to live on one part of the interface and the other side that likes to live on the other part of the interface. And if you pack the surfactants around the outside of a bubble, you can stop it from closing. So you can ask yourself, does the batter, right, that Joanne used have any surfactants in it? And the answer is, of course, yes, because she used butter. And butter is a milk product, and milk has proteins within them which absolutely are surfactants. There are the casein proteins, for example, which might be coating the bubbles in the batter after she makes it. So that's one possible explanation, that the surfactants are protecting the bubbles from closing. The other possible explanation is that actually the bubbles are just closing, but that the batter is so viscous, it's so hard to make flow, that the forces that are causing it to flow are small enough that it just takes a long time for them to close, and long enough in particular for you to go forth and cook your cake or bread or whatever it is that you're going after.